Hello, you are welcome to Maths Clinic series. In this video, we are continuing the series of logarithms, and here we want to look at properties of logarithm, which happen to be the third key you need in order to solve series of questions in logarithm. Now, by the end of this video number 4, you should be able to identify the properties or rules of logarithms with series of examples that goes with them. So we'll start with property number 1. Property number 1 simply says log base AA is equals to 1. That means log of a number of the same number will always give you 1. So we can write by saying logarithm of a number of the same base is equal to 1. Example, if I have log base 2, I can easily write 1. If I have log base 4 and 5, of the same log 4 and 5 will give me 1. Log root 3 will give me 1. Even if I say log base orange of orange will still give me 1. Well, that's just for fun, right? That's just for fun. Property number 2. If I have log base A1 is equal to 0, what it means is that no matter the base here, if here becomes 1, if we have log of 1 to any base, the answer will give us 0. That is on condition that the base will make it define. Okay, if the base will make it define, log of 1 to any base is 0. So log of 1 base 23, I'll write 0. Log root 5 base log 1 root base root 5 will give me 0. All right, that's okay. Then log m of 1, log base m of 1 is 0. So if the base become banana and it is 1, we still get 0. All right. Then property number 3. Here is very critical. Log of any negative number, no matter the base, is undefined. No matter the base is undefined, unless probably the base is also of the same negative number of the log. Probably then that will give you 1, as we said earlier on. So logarithm of a negative number does not exist. So what are we trying to say here? If I have log base 3 negative 9, don't bother yourself to write any answer because it will be undefined. Let us assume that this is not undefined and I have log base 3 negative 9 and I want to assume it to be, let's say, x. Then per the definition we learned earlier, we can say 9 is equals to 3x. Now negative 9 can be written as maybe negative 3 squared, and that, yeah, negative 3 squared will give us negative 9. Don't forget that. Let me clarify myself before you take me on. I said negative 3 squared is equals to negative 9, not positive 9. Unless I write it negative 3 all squared, then that will give me positive 9. Okay, it's an error to say this is going to give us 9. Be careful with that. So you can see that here, if the bases were to be the same, you could have said the answer would be 2. S would be 2. But the bases are not the same, so we can't equate the answer. And it will be very difficult to simplify this to make x the subject. And so we say it's undefined. So if I have log base 2 negative 32, I will still say undefined. Log base x negative 2 will still give me undefined. Property number 4. We are going through 6 of them, so we are number 4. Now check this one. If I have if I have a number raised to an exponent of log of a base of any number here, so far as the base here remains the base of the real number, then it means that we are going to get this number to be the result. That's a property. If I have 7 raised to an exponent of log base 7, 15, then I can say the answer is 15. 3 exponent log base 3 2x, then the answer will be 2x. That is as simple as that. Then property number 5. This is more or less like change of base. If I have log base log base BA, then it's the same as 1 over log base AB. It's 1 over the reciprocal. And this is true because I keep my B and then A interchanged. Alright, so this is very true because if I try to write this as change of base, then I could say log base A of A over log base A of B. That is, if I'm to change this one to base of A, this one to base of A, then it means log base AA is 1, which will satisfy this one, and then log base AB will be as such. So that statement is true. So if I have log base 16 2, it will be the same as 1 over log base 2 16. So you can do that, and this also will give you that. Then finally, this one is more or less an advanced form of this. If you try to cross multiply this, which is over 1, they are going to get 1 is equals to this times that. So what it means here is that if I have log base BA multiplying by log base AB, then the result will give me 1. You get it? Example, if I have log 232 multiply by log 32, log base 32 2, then the result will just give me 1. That's as simple as that. So that can also give me that. Okay, so that is that for that. Now we want to take note of this before we end this part of the video. Logarithm written without bases are in base 10. Take note of this. Anytime you write logarithm or you see log being written without base, then assume it's in base 10, and that base 10 makes the whole of this log to be called common logarithm. So logarithm that has base of 10 are called common logarithms. So if I have log x, it simply means log base 10x, and that is common logarithm. Now ln x is equals to log base ex. This one is called natural logarithm. If you see this on calculator, it simply means natural logarithm. And normally we pronounce it ln x. Ln x. That is more of relative math, so we leave it for those who are doing advanced mathematics. So with this, we come to the end of video number 4. So the next video, I'm going to look at a series of examples that will take care of all we've learned in video number 1, 2, and 3. Thanks so much for watching.